Today we're going to be talking about sequences, which is just a list of numbers, and the domain is the set of positive integers. That means is when we talk about your first number in my list, we're going to start with a sub 1 and then go up by integers to a sub 2, etc. So what you want to be able to do is write the first couple terms of a sequence. So this is my general expression for a particular sequence. So if I want to come up with a sub 1, it would just be my first term in this sequence or my list of numbers. You're just going to plug in 1 for n, so 4 plus negative 1 is 3. A sub 2 would be plug in 2 for n, 4 plus positive 1 is 5. And so the pattern continues, and I can come up with the next two terms. So these are your first four terms of my sequence. Same thing, this is my general term, so if I want to come up with the first four terms, my first term would be plugging in 1 for n. In this case, you're going to get 3 halves, which is 1.5. My second term is plug in 2 for n. You're going to get 2, and so the pattern continues. So these sequences are defined explicitly, so you have an equation or an expression where you can plug in the n. There are certain sequences that are defined recursively. All that means is that you need the previous number to get to the next number. So notice that I give you the first term is 25. And then you're going to use this formula to come up with all the other ones. One way to think about it is n plus 1 is just the next number. So to get to the next number, the next term, you take a sub n, which is the one before n plus 1. You take the previous number and subtract 5. So that would give me 20. Again, to get to the next number, you take the previous number, which is 20, and subtract 5. You can do it that way, or another way to think about it is, in order to find a sub 4, which is the fourth term, I need to really plug in a 3 here. So if I plug in 3 here, I end up with a sub 4. If I plug in a 3 here, it's a sub 3 minus 5. So the formula says take a sub 3, which is this one, subtract 5. So this is called a recursive sequence. What we are most interested in sequences is we want to know if that list of numbers approaches a particular value or the limiting value. So such sequences are said to converge. So if you look at this sequence here, I've listed out the first couple terms for you. We're trying to see if I keep listing this out towards infinity, is it ever going to approach a particular value? As you look at these numbers, notice the top is 1, the bottom gets smaller and smaller, so it looks like it's going to 0. So we say that this list converges to 0, or we can also say it using this notation. As n goes to infinity, as this n gets bigger and bigger, the list goes to 0. Okay? So if we have a sequence and the limit of that sequence approaches a value, then we say the sequence converges to that number. Otherwise, we say it diverges because there's no one single number that the sequence approaches. So let's look at a couple sequences and see if it converges or diverges. So this one. One way you can do it is just start listing a couple, first couple terms and see what happens. Notice if I plug in 1, this is 4, then I get 6, then it just keeps going back and forth between 4 and 6. So this sequence does not approach a particular value, so we say it diverges. Okay? Or another way to talk about it is we say that it oscillates, goes back and forth between 4 and 6, but this sequence diverges in the long run and never approaches one particular value. So this is one way you can do it. Start listing the numbers and see if you see a pattern. Sometimes this may be hard to see if it doesn't just alternate between two numbers. So sometimes it's probably the easiest in most cases to actually go ahead and take that limit. So this limit, when we go to infinity, degree is the same, so we do the ratio of the lead coefficients. So this is negative 1/3. So we say that if you look at this list of numbers, this sequence, it is going to converge to negative 1/3. That's the number it converges to. Okay. So why don't you pause the video, try these 4 problems, and come back and you can check your answer. Okay, A, I can rewrite this like this. This is your general term. So if I take the limit of that general term, this is 0, so we say it converges to 0. B, okay, this is a limit from going all the way back to chapter 6. this limit is actually e. E is a number, so this sequence is going to approach 2.78, etc. So we say this converges. Okay, let's take the limit of the last two. This limit, and since this is defined as b sub n, I can just write it. This is going to give me -1/2. So again, this converges. Last one, this limit. Okay, you can do L'Hopital's rule multiple times, but you have a polynomial on the top, you have an exponential on the bottom. In the long run, the exponential will always grow faster. So the bottom will outpace the top, so this limit in the long run is 0, so this also converges.